Today we're going to talk about chemical reaction rates, which is how fast chemistry happens. How fast two molecules might bump into each other and become a new kind of molecule. And there's a lot of different things that can affect how fast chemistry happens. Today we're just going to focus on concentration. And to do that, we're going to use an old standby chemical demonstration called elephant toothpaste. What I have here is some hydrogen peroxide and some sodium iodide, which is kind of a salt kind of thing. And I'll mix the two, and this should create a lot of bubbles of oxygen over here, and it'll foam up and be all really cool and exciting and be wicked fast. All right, ready? Here goes nothing. Oh yeah, look, there it is. It's bubbling. Ooh, bubbling away. Now this is 3% hydrogen peroxide. What you could buy at the store if you want to clean out a cut or something like that. Be careful with hydrogen peroxide because it gives off oxygen gas. So you can see here it goes. It's still bubbling off. Oxygen gas is coming out in a little foam. And I put a little bit of soap in there, dish soap, and that's going to make this cool little foam. And it's still going. So pretty cool. And we just may have to put this on stop time. And remember, this is 3%. 3% hydrogen peroxide. It's still foaming, and it's going to make a mess now. There it goes. Ooh. Classic. Maybe I'll go, oh here, look. You can see it filming over the side, huh? Beautiful. 3% now. Yeah. Still going. So this is a reaction rate, right? The more hydrogen peroxide that's in there, the faster this should happen. That's one of the things about concentration. The more of a substance, the more concentrated a substance, not just how much it is, but more concentrated, the more likelihood that two molecules will collide and then have a reaction happen. So in this case, the salt and the hydrogen peroxide molecules will collide, and then you get a reaction happen. And the more likely they are to collide, the faster the reaction will happen. And since we have less concentrated hydrogen peroxide in here right now, it doesn't happen very fast. Well, this is still moving kind of slowly, very slowly. So we're going to clean this up, and let's try it with 30% hydrogen peroxide.
30% hydrogen peroxide is much more concentrated, so it shall happen faster. There it is. Nice and fast. Look at how fast it's happening. That's because chemistry happens faster because there are more molecules present to collide with each other to cause the chemistry to happen. And when this reaction happens, it causes bubbles, so we get lots of bubbles when it happens fast. So 30%, it happens really fast. Now let's just quick back it up and just compare one more time the 3% to the 30%. So, going back in time, zoom it right on back, and we start off with the 3% hydrogen peroxide, and you can see that there's not very many molecules. Well, you can't see that, but it's moving very slowly because the collisions happen slower. They don't collide as often to cause the chemistry to happen. And then if we kick it up a notch to 30% hydrogen peroxide, the chemistry happens much faster. Boom. There it goes. So we've learned today that the more concentrated your chemicals, the faster your chemical reactions will happen. And as an added bonus, the more concentrated your chemicals, the more impressive the chemical reaction. Of course, it's the more dangerous chemical reaction too, depending on what your chemicals are. It's not the amount of chemicals you have, but the concentration that will determine how fast the reaction happens.